We've got the recording on. There we go. And it uses what's called a document-oriented model. This is also sometimes called like an object store, but what this means is that it looks like JSON as opposed to the table-related models. And it doesn't store it quite in JSON. It's in BSON, which is basically JSON, but not just a string. It's compressed to make it more efficient, things like that, and fast. But the way that we interact with it is going to look a lot like JSON, but internally it represents that slightly differently. Now, MongoDB works with stuff besides JavaScript. You can use MongoDB with plenty of other systems. In fact, a lot of stuff that isn't JavaScript still use JSON objects or JSON notations when communicating stuff back and forth. It's just a really good data interchange format, pretty well supported. And so there's a ton of people that also just store data in that particular way, not just Node.js. So you might, even if your backend isn't a Node backend, you might still be working with MongoDB, though it does make it particularly easy to work with a Node backend. So if we look at a relational database, we just finished doing that with project 2. If we wanted to say have a book table, we could have this where we have the ID, the title, the author, when it was published, and then we might have the author, their email, their phone number, stuff like this. And so what we see here is because if we wanted to represent this as an object, well, we'd probably take blahmatic and then just embed author, email, and phone number. Can't do that with SQL. We have to use joins where we would say, let's join the author field here and the author field here to get all of the relevant information. NoSQL doesn't do that. As you can see here, we've taken the author and we've just embedded that information directly into it, like we would with a data object. Now this works really well, especially when the structure of your data is going to change from object to object. And that's what we mean about heterogeneous data formats. Not everything in a collection, which is kind of the equivalence to tables, needs to have the same structure, unlike in MySQL where everything needs to have the same structure. So it works really well at data formats that are different from each other. For example, if this person, the author of this one had, let's say, no phone number, or this one we wanted to add in like a website here, we don't have to necessarily say that ahead of time. So MongoDB is very forgiving. So if we're looking at the organizational levels, we still have the idea of a database server up at the top and then a database. But once we get past the database level and start looking at tables and collections, things start to work a little bit differently. You might think of a collection as being a table, even though it's technically this different thing. It's dealing with that same level where here's a bunch of similar things is what a table is, and a collection is here's also a bunch of similar things, though with a little bit less constraints. The individual document, you might think of it as being kind of a row because it's got a bunch of values filled out, but it also has columns that can vary from 1 to 1. So a collection is composed of multiple documents, and the document is kind of the smallest unit that you're going to work with when you're working with MongoDB. So this is just a rough similarity. They actually end up being kind of different. This is more what their purpose is than necessarily how they're organized in the hierarchy of it all. So obviously the databases up at the top need to have a database before you do anything else. A collection is going to be your group of things. If you want to say, like, let's find all of the books, you're going to be doing that at the table or the collection level. And then the next one would be, hey, if I want specific information about a particular book, I'm going to look at a row of it or a particular document. Or if I want to know a specific facet of that book, then I'm going to be looking at the column or the field. That said, we're going to sort of use our CRUD analogy to kind of look at how we can do different things. before we get too deep into this, we're going to make sure everyone has all the necessary stuff installed. We're going to have a tool like MySQL Workbench called Robo3T, and then we're going to have something like MongoSQL Server, that is the MongoDB section. Now, if you look in the supplemental folder of 17, you're going to see this section, this README, which is how to install MongoDB on your machine. It'll be different depending on if you're on Windows or a Mac. And then once all of that's done, you can start it all up. The other thing, this is how to set up the MongoDB server, as it were. This is what actually houses all of that stuff. And then you're going to also get Robo3T. Now, Robo3T used to be called RoboMongo, and then the people that owned MongoDB said, hey, you can't do that. And so they changed the name to Robo3T. So if you occasionally see references to that, that's what it's talking about. So you'll notice it's robomongo.org, and then it's just labeled as Robo3T. So they're going to try and push you into Studio 3T, 3T only, or Robo3T only. We're going to just be working with Robo3T only, this one right here on the right. At a lot of points, they might try and funnel you towards the Studio. We're just going to use this one. So again, it's like, hey, download your Doppelpack. Download this one on the left. Do you want to click on this one? You don't need to fill this out, or do you now? I have an older version where I didn't need to do that. And then, so you fill out your email, first name, last name. I wouldn't give anyone a phone number. And then you can download it and you're good to go. And then from there, you'll receive it as part of your information there. So let's fill that out. So let's go, here's my work email. It'll pop this up, and then you'll install it like normal. So I'll go ahead and Slack out this link right here. Remember, you want to work with Robo3T, formerly RoboMongo, when you're downloading that. So I'll post that in class activities. We're going to open up the breakout rooms at this point, so help each other out if you're getting stuck on any particular step. And if you're running into issues still after that, let us know. We'd love to help you out. Cool. So I'm going to post a link to this. And then also I'll fix the permissions issue on the slide, but we're going to open up the breakout rooms at this point. If you have questions, let us know. We'd love to help you out. Good luck.
I see the judgment.
There's no judgment. What?
Alrighty, folks, we're mostly back here at this point. What we're going to do is if you're still encountering issues getting set up, that's okay. We're still going to give you some more time during this activity to start working with that, but we want to sort of, for the people who are set up and ready to go, we want to make sure that y'all have got some stuff to be learning and working with. So if you're still running into issues, we'll let us know. We'll have TAs help you out in terms of getting everything finished set up, but we want to take some time and just look at, hey, let's continue working on this stuff. Now, this is Robo3T. This is our equivalent to the MySQL workbench. And just like that, we need to connect to our service, which is running. Now, if you've got your service running correctly, you should be able to click on one of these. You probably won't have any connections on here. I've demoed this a couple of times, which is why I have all of these different ones. But you can, all of these buttons up here are just add, remove, edit, etc. So what I'm going to do is I'm going to click create. Localhost is my host. The default port for MongoDB is 27017, just like 3306 is for MySQL. That's just your default. Pretty much everyone probably will have installed that. Now you can click test, and then it should come back. Everything's good. If that didn't happen, then you've got some issue going on at that point. But you shouldn't need anything else. So you literally just make a new connection. You might name it something like local connection, but you can literally just make a new connection and then click test, make sure that it works, click save. This is now your connection to that database. And if you click here, you won't see as many databases as I have here, but you should see, I believe, config on there. You'll probably see one or another. So these are our different databases that we have here. Now, specifically, I'm going to right-click on local connection and click Open Shell. What this lets us do is this is kind of like the SQL Workbench query tab. This lets us write things directly for us to work with. Now, unlike SQL, you're going to notice that we don't have to set up the structure of things a lot ahead of time. MongoDB just kind of goes, hey, tell me what you want to do, and then I'll make the structure for it right before you need it, keeping in tune with that sort of heterogeneous data that we're working with. It's not prescribing or making structures until we need them. So I'm going to write up at the top, and I'm going to write these things out here because it's a little bit easier to see them. Oh, that's a bit much. There we go. So the first thing that you would do if you were doing this in SQL, you would say something like create database, and then let's say LessonDB, the name of the database. This is what we would have done in SQL. That's not what you do for MongoDB. When you are doing this in MongoDB, you just assume that it exists, and you just, instead of having to say use create, or maybe drop it if it doesn't exist, like you might see this at the beginning of a bunch of stuff. For Mongo, you just see use lesson DB. You just say use it. Doesn't matter if you don't see it in your list of schemas already. You just start out with that. So if I copy this over here and I run it, oh, I don't need the semicolon. There we go. You'll notice it says switched to DB lesson DB, and which I don't believe I have over here. Correct. And if I refresh on my connections, you'll see that it doesn't exist because MongoDB won't make it until you put data in it. And it's not going to make an empty database to just take up space. It's going to wait until you actually put documents in this section somewhere.
Is
So
Mongo not case sensitive?
Mongo is not case sensitive. I believe. So let's go ahead and run this. You can do that by pressing Command or Control Enter, or F5, or you can just click this button and it'll tell us what that is. Usually I do pretty much everything lowercase when I work with Mongo, or I make it look like JavaScript functions, things like that. So things are inner capped along the way. Cool. So that will show me what databases I'm on. And if I wanted to, next thing I would have to do is I would have to do something like create table. Let's say that we're talking about a list of countries. And then I'd have to specify, or let's call it places a little bit more generically. And then I'd have an ID column, int, not null, auto increment, and then I'd have to say, oh, and it has a continent field, and it has a country field, and it has a list of major cities, except, oh man, I can't really store that data there, so I'm going to have to make another table called major cities that has references to that place in SQL, so you can see that that could get out of hand really quickly. We don't got to do that in MongoDB. We're just going to say db.places, where db is just our shorthand for whatever database we're currently in. So after we set use lesson db, the value db is now the lesson db. Places is our collection. Similar to the tables we would use up here, and then we're going to say dot insert. Dot insert, as you might imagine, which CRUD action do you think that maps to? Any guesses?
Create.
Create, totally. So, and then I basically put a JSON object here. And we can do certain things where we could say like, hey, the continent, let's say that we're doing Morocco. So the continent is Africa, and the name of the country is Morocco. And then some of the major cities on there. And previously, if we were using MySQL, we'd either have to make this a big string that just said a bunch of names. But with MongoDB, we can just embed that data directly in here. So we're going to say major cities, and then we're going to put an array. And then that array, we could start it out with strings. We could do objects themselves. So I'm going to say Casablanca, obviously a very big one. And then we've also got Fez and Marrakesh. I think I'm saying that right. I'm sure some geography buffs or people from that region can correct me. So that's it. That's all we need. We don't need to say that the table exists. We can embed information as arrays already in there. We can just treat it like it's a giant JSON object. So I'm going to copy this into here, and I'm going to run the whole thing. Let's see, get rid of that. And get rid of that.
Do you need to include that use lesson DB?
If this is set to lesson DB, then no. Let's see. And so I've now inserted one record in here. So now if I refresh this list, now lesson DB appears because there's a document in there. It won't do that until you have one. If I look under my list of collections, there's places. Did I have to make it beforehand? No, it's just there. And then if I right click and click view documents, I can see the different pieces. You'll notice that it has a field on there called _ID, and then this object ID, and then a big string of letters. That's equivalent to the ID field. And object ID has a few more wrinkles about it we'll talk about later, but then we see the continent, the country, the major cities, etc. are all set up there already for me.
How did you refresh in the Mongo?
You just right click on it and there will be
Okay.
something called refresh.
Yeah, got it. Sorry, thank you.
Hold on just 1 second. There we go. All right. So that's how we create something. The next thing I want to talk about is also how can we read this information. So db.places, and then we'll just say .find. If in fact, when we came up here, you'll notice that we have db and then they do an extra step of get collection places, but you can simplify that to just db.places.find, and then an empty object means no criteria, which means we can find it. Now, we can also, let's go ahead and make some other countries real quick. Pick another country for me. So let's pick another African country to start out with.
Chad.
Chad. So we've got, what are the major cities in Chad? This is when we go to Wikipedia, right?
N'Djamena.
I'm going to have to look up the spelling. I'm just going to say that already. All right. Okay, so N'Djamena, and then we'll just take these top three. N'Djamena. And there's a pretty big jump between those two, almost 1 million people and then like 100,000. Cool. So let's run this piece. Let's do another country, one that is not in Africa.
Argentina.
Japan.
Argentina and Japan, we'll add those up. So South America, Argentina. I know a little bit more about the Western Hemisphere. And I'll count on some people to handle that on Wikipedia for me. Country, Japan. Fix the spelling there.
So I accidentally added the first one that we did twice, and it just made two records with individual IDs. Is that that's just how it goes?
Okay, you just have another one, the same as you would do insert into. Now you can get rid of them. Like if you want to look at your places, you can like view documents, and then you can be like, I want to get rid of that one through the UI by just looking at a list of them and then right clicking, and you can delete or edit them pretty easily. So with Japan, I know we've got Tokyo, we've got Kyoto. I don't know any other permutations of the same letters.
Matsuyama.
Spell that one for me.
MATSUYAMA.
Awesome. And then I'm just going to put Buenos Aires as one right there. There's other ones. I'm sure I'm just not looking them up for time. So let's grab those and we'll add those into our list. Again, and you'll notice we inserted one, and then right after that, we inserted another. So I'm going to right click, view documents, and it does the find, and here's each one of them. Cool. Now, if I want to list some of these individually, I'll go ahead and Slack these out for y'all if you want a copy of them. Let me make sure I get rid of semicolons real quick. I'll post this in class activities. Oh, and Corey has provided me a list of some of the other big cities on there. So through the UI, we can just do this where we can say like, I would like to edit this document. And then it kind of pops this up for us, and we'll go ahead and add 2 more of them. I'm going to be missing accent marks because I don't remember the alt codes, but we'll just work with that for now. I can validate it to make sure that the JSON is valid, and then I can save it. Now it's updated. That's through the UI. We'll be looking at the commands that do that, though you can kind of watch them behind the scenes. So now, if I wanted to, for example, find a list of all of the African countries, any guesses how we would do it? It's going to feel a lot like we did for Sequelize. If I want to find all of the...
Sorry, find where continent equals Africa.
The thing is, we don't even need where, because find already kind of tells us, hey, we're just looking for something. And we just say continent, Africa. So this will get me a list of all of my African countries, which is the 2 that we established earlier, namely Chad and Morocco, which is pretty cool. Not a lot of typing involved to do that. Now, let's try doing it with a specific ID. So let's say that I want to grab this line right here. If I change this to just be db.places.find, and I say underscore ID is this big string, it's not going to work correctly. It's not going to work correctly. So let's run that. Oh, get rid of that really quick. Come back here, run this, and it's going to say, hey, we couldn't find any records. Because this isn't the object ID. This is the key that we give to the object ID function, which will then in turn generate the actual ID that is being used. So when you search by something, you need to include the fact that you have this object ID function around everything. So if you just have the string by itself, that's not enough. That's just the string representation of the key. It's not the actual key itself. So you have this function called object ID that translates it from the string, which is easy for us to write, into the actual key, which is easier for the computer to work with. Which is why it's written as object ID, the rest of it. Cool. So what we want you to do is to try and insert a few records and find a couple of different records. If you're still having trouble with your database, this is when we'll be able to help you out with that. So all of the pieces that we just did are inside of this section, O1 instructor, create, insert, and find. The only difference is the countries that we used. And what we want you to do is to try doing it with a different set of data. So insert trees about yourself and the people in your row in a student's collection. In this case, we're going to replace row with breakout room. So the other people in your breakout room. So each document should have the following, and instead of row number, you'll choose breakout room number. So a field of name with the person's name, a field of OS with which one they have, and then a field of hobbies, which is going to be an array of the different hobbies, a chance to kind of get to know your, I guess, roommates in a sense. And then we want you to write some queries, a list to find everyone in your particular breakout room, trying to find a specific person, and then lastly, try and find all the people in your breakout room that use Macs as their OS. Or as a bonus, you could try and look for everyone that has a particular hobby. So check if there's an entry in an array. So if you're looking for people in your breakout room with common interests, how would you do that? So we're going to be working on this for the next, let me check the schedule here. For the next 10 minutes. If you're, actually we're going to take a little bit longer than that. The next 15 minutes, if you're getting hung up on MongoDB, just let us know in terms of getting everything set up, and we'll be able to help you finish your setup. Otherwise, go ahead and work on this activity, and then we'll look at some other stuff like updating and deleting data next afterwards. Cool? Good luck. All right, folks. Still waiting for everyone to pile back in, but hopefully you were able to get this set up. If you're still working with MongoDB, being set up correctly, we're going to take some time with the next activity as well to make sure everyone's set up as well. And fortunately, MongoDB is relatively straightforward in how it does things. It feels a lot like the way SQLize does. So if you got comfortable with the way that SQLize does things, it feels pretty similar, which is a nice thing about it. So since we've got everyone back at this point, we start out with use classroom, just to say, hey, this is what we want to use. And then we say db.students. And for students, what's the name of this? What do we call students in this case? Like the thing that goes after that? The name of this isn't a table, but what?
Collection.
It's a collection. And so then we insert in this information. All of this information is specific to the what? Not the row, but the
document.
And each one of these isn't a column, it's a what? Like name Steve isn't a column, it's a what?
Field.
It's a field. So we were able to introduce this, and unlike with SQL, we can just insert arrays directly in there. Now, is it possible to just insert JSON data as a string into a MySQL database? Yeah, but you lose a lot of the benefits like being able to search and find things. So if you were just doing it by ID, okay, sure. But most of the time we want to do things like finding all of the students in row 3 like this, where we can say, hey, db.students.find, and then essentially we have the where clause without having to say where for it. If we want to find a student named Steve, we can do that based off of the name. If we wanted to do it based off of an ID, we would say object ID and then in parentheses or in double quotes the ID. Now, unlike MySQL, the IDs in place aren't just enumerated one after each other. They're just a big, long, random string, so that you can't just kind of enumerate one after another. It's not easy, for example, to guess what the next one would be. Like you can't say, oh, I'm user 546. There's probably user 545. Let me see if I can do anything if there's vulnerabilities there. And that's one of the reasons that you don't see them just being numbers one after another. You can combine these. This would be read as find the students in row 3 and that use a Mac. So whenever you see these two together, it's and, it has to match both criteria. And then we have this other piece here. And so just like we had sort of operators that would do validations for us, in SQLize, we see operators here for selecting things. Now, if I had this written and I just wrote hobbies coding, like so, this would only match with people whose only hobby was coding. So this would only match people who have coding and no other hobbies, versus if we do it this way, this is going to find people who have coding in their list of hobbies. So they could be interested in other things like underwater basket weaving or extreme extreme sports of some kind. Extreme underwater basket weaving. Yeah, it's the new X Games. Tony Hawk is going to be doing it. It's amazing. Stay tuned.
Sorry.
Go ahead.
That's really funny, but is there a way to, so instead of doing like multiple insert statements for each individual person, is there a way to insert multiple at once?
Yeah, there's a command, I believe. I always get it mixed up between different libraries, but I think it's insert many. We'll do that for you, where you can insert a lot, or it's bulk insert or something like that. But
then does it do like, then is it similar like name and then an array of names and then array?
Well, you would treat each one of, you would be give it a bunch of documents. So if you wanted to insert many, you would be like document 1, document 2, document 3, document 4, one after another.
So it's similar to like a classic object where it's like in the parentheses, then followed by a comma, next
Right.
one, so on.
Right. And I believe you just pass it an array of documents, and it's good to go at that point. And it's bulk insert many. I've worked with enough libraries that, and they are all named things, but yes, you can do that. Short answer. Cool. So we've got the first 2 entries of CRUD kind of mapped out, where we would say DB, let's say let's continue working with our places example. So db.places.insert, db.places.find. Anyone want to guess what update is?
Update?
Update. And unfortunately, it's not as good as destroy for the other one. We're working with remove on there. So sorry, I didn't make that decision. So let's take a look at some of those. So everything generally follows this principle of db.collection name, so db.places. Now in this case, db.places, the first one, like we were doing with updates in Sequelize, the first one is going to be selecting what we're updating to. This is selecting, hey, find all the countries that are in Morocco, and we live in some science fiction universe where now it's moved to Antarctica. Morocco just up and left. They attached a bunch of booster rockets to the bottom of the country and just flew off, I guess. And so this says, I would like to change the continent to Antarctica. And so this says, I'm just going to change this particular field to Antarctica. Now, unlike with Sequelize, this will only work on one thing by default. It's going to find the first one that matches this criteria and update it. If you want to do subsequent ones, you'd have to include this option at the end here, multi-true. So by default, update is kind of update 1, where it's just going to update one particular entry. And if we want it to be update many ones that could potentially match that, then we call update with the multi argument set to true. Now, another thing that we can do, let's go ahead. So this was the structure for inserting things. And then we've got db.places.update. Keep doing that. And a nice thing is that column, much like with JSON objects, doesn't have to exist ahead of time. So there is no capital column, or not column, but field from this insertion statement. But we can follow it up with this. Capital is a new field. We're setting it to be Rabat, and it'll update that. How many will this update? Will this statement update? Or
One.
at most, I guess.
1.
At most 1. If it can't find anything that matches it, 0. So if we didn't have Morocco in the database. But under our current data set, just 1, even if we had multiples. And we can add the field, capital, to it to be new. So
And what if you did have multiple?
it would, then if you did that, it would do that for each one of them.
But so you had multiple, but you only wanted to update 1. Would you have to get way more specific and then just do it by ID?
This would just do it as the first one that it found, which would typically be the first one that you actually added to the database.
So what if you wanted to update like that second instance? If it's like you're searching by a name and there's
then you would probably use the object ID in that particular case. Next, we want to see, sometimes we don't want to add a new field. Sometimes we want to work with an embedded collection, like our list of our major cities. I think that's pronounced Agadir, but I'm bad at names notoriously, and that's on me. That's not on anyone else. And so this is going to, again, find the first thing that matches, and then it's going to add into that list of, it's going to say, hey, major cities, I want to add in the entry Agadir. Because if I used set and I just said major cities and then parentheses Agadir, or square bracket Agadir, I would be removing all of the additional ones. So it's the difference between setting things to be specific stuff and then removing particular items. Now, we can also remove items from our collection. If we're like, hey, we added too many things called Morocco, we can just call remove. We can even remove collections themselves, and we could even drop the whole database if we want to. So the difference between DB places remove and DB places drop is that this removes all of the items in the collection. So now this is db.places is going to be an empty collection, but still there. And this will get rid of the collection itself. Now, that doesn't end up being too big of a difference in MongoDB, but it is a difference. And then if you want to get rid of the whole database, you can just say db.drop database, and it'll get rid of it for you. Now, a lot of these things you can also do in the UI. And I want to look at how we can do that real quick before we have you practice some of the statements. So one thing you can do is you can just create a new collection if you want to through the UI by just right-clicking on collections, and it needs a name. Let's call it like students. And you can right-click on that, view documents that we saw already. We can insert a document, and then it'll basically say, give me the JSON object you want to put in there. So in my case, if I just want to include like name, we'll go with the example Steve, and then the hobbies. And again, it'll need to be valid JSON, so you tend to want to put the quotes around the front there. And let's say extreme underwater basket weaving. And what would be a interesting mixture? Like, I'm into extreme underwater basket weaving and
gardening.
Let's say peaceful on land gardening to sort of contrast the two. So I'm going to validate this, save it to the database. Cool. And now it's just there in my list of documents. Now maybe I say, I'm just going to say gardening, specifying that it's on land feels a little bit odd to me. You can actually just edit the document and just come in here and edit it and save it. Now this is great for just, hey, I need to make something really quick in the database, or I want to edit something really quick without having to go through all the select statements. But what it does is it actually generates all of the changes for you in that case. And then if you say like, I actually want to get rid of some of these, or I want to get rid of this document, you can just click delete document, or you can delete or drop the collection, or you could just drop the whole database if you want to. So the UI gives you a lot of easy ways of interacting with the database with MongoDB, which is a nice thing about Robo3T. It's really easy to just change it to be exactly what you want. But you should know these as well, because these are what we're going to base our node operations on as well. Now, for this next one, we want to give you a little bit of more practice, specifically with update and delete. And so we're going to take that student database you just made, and we're going to model some events happening. So you get into extreme basket weaving. It doesn't have to be underwater. I know when I first heard about underwater basket weaving, I thought that meant you had a scuba tank, not that your hands were just submerged. So unfortunately, it was a little bit less extreme than I thought. And then you have some other tasks like adding new fields, and then updating those new fields as well. Cool. So there's a few guides listed in the bottom of the README if you get stuck. If you, we're going to continue to help people who are still getting set up with MongoDB if you're running into any issues at the end here. And then we'll look at some other operations like sorting, and then introducing, hey, how can I connect to this with JavaScript? How can I run these commands not just in the workbench or in Robo3T, but actually from Node? So we're going to open up the breakout rooms at this point. If you're still having trouble getting configured, or if you just have questions about how to do something, let us know. We'd love to help you out. Good luck. Alrighty, folks. Let's go through this real quick. Then we're going to say a brief word about how to do sorting in Mongo. And then after that, we're going to look at, hey, how can we connect our Node applications to Mongo so that we're not just running these applications like in storing data in an interesting way, but until we can hook up a program to it, not as exciting for us. So when we decided to take on a new hobby, let's say that we're Steve in this case. So we're going to say db.students.update name, where the name is Steve. We're going to push in to the hobbies array, extreme basket weaving. Cool. Now, while practicing for our extreme basket weaving competition, we broke someone's computer. Things got crazy in there. So they're going to get a new operating system. So we would say students.update whoever the neighbor was, and we would use set here. What's the difference between $push and $set?
Set's
That will change
updating.
the value.
Yeah, so set is, this is exactly what it is, versus push is more of a mutation where we're just adding something to what already exists. But we know exactly what OS is now. Just by looking at this alone, you wouldn't necessarily know what the state of hobbies was unless you knew what else was going on. So we're going to set the OS to be, I don't know, Mac, PC, Linux, Temple OS. There's a whole bunch of different things. Next, so db.students.remove, the name of another neighbor. We can update everyone, no criteria, and multi is set to true. So this updates everyone, and we're going to say that we have currently not given everyone candy, but we want to keep track of it. We're going to start out with candy though, so we're going to update ourselves to have candy. Cool. Now, if we wanted to insert a bunch of people at once, this is how we would do it to reference the question that was asked earlier. So db.students.insert many, and then just an array of the objects. Just an array of the different documents, one after another. And so we've got Jane, who's got the hobbies of coding, sleeping, and karate. Then we've got baseball, basketball, and Tai Chi for Mary. Alexa likes gaming, reading, and gardening. Gary likes walking, reading, and mountain climbing. And Ed likes coding, karate, and scuba diving. So we want to return all documents of students who have reading as a hobby or a Mac operating system. So who would that be? Who would we see as people that either enjoy reading or have a Mac?
Alexa and Gary.
So they have to enjoy, if we look here, Mac
Jane, Mary.
gets included. Mac
Yeah.
gets included. Lynn, or I don't know why it says Lynn there, but all right. Alexa has one called Linux. Oh, that's why. But has a hobby of reading, so they're included. Gary has a Mac. Ed has an OS of Windows and doesn't have him, so we should see everyone but Ed in this case. And the way that we write this is we use the OR operator. By default, if we just listed each one of these, it would be an AND, where we would see people that liked reading and had a Mac. So in that case, we would only see, we would only see Gary if we did an AND operation. Versus this is how we would do OR, where we provide an array of the different conditions. Now, if we wanted to do this and people who were in the row, we could then also say, oh, in addition to this, I also want people that are in row 3. So what this would do, I'm looking for people in row 3, and they have to have one of the following criteria. So you can combine your ORs and ANDs and nest them further this way. So we could say, if we wanted to open up these, say you have to be into reading or gardening, you could do the following. Or if you wanted to say, hey, I also want to say, hey, you either have a Mac or you're also in row or in some row 3 or something like that. You could even nest it further, where you would say, all right, $ or an array, and one of those would be, this is my OS, and in this case we don't, let's say Mac. So if you have Mac or Linux, or you're in row 3. So you can have as many and or conditions as you want just by nesting them appropriately. Now, the more you do it, the easier it'll get. It can feel a little weird at the beginning, just getting used to it, but it's certainly achievable. And just with these techniques, you can have really powerful queries. We'll look later at how you can even join information from different collections together with the populate method. But I want to talk about, we've only got 3 minutes left before lunch, and I want to talk a little bit about sorting. Now, if this was a table and I said select star from students, how would I order them by the row?
Order by.
Order by, and let's say that I want to start with row 1 and then go to like row 5 at the very end. So
Ascending.
or ascending, yeah.
Ascending,
So I would,
yeah.
by row, ascending, meaning I start with the lower one and I move up. I'm sort of moving in a positive direction. If I wanted to go from 5 to 1, then it would be descending. And usually you just see that written as DESC. like so. And you could think of it as each time you go forward, you're adding a negative number. You're going down in that particular case. And so we borrow that convention if we're talking about a list of animals. So let's say that we've got a list right here. So here's an animal. For example, it's a panda. It's got a number of legs. It's got a class of mammal, and it's got a different weight to it. And I happen to have a list. I believe I still have my list of animals. There we go. So for example, here's a panda. It's got 4 legs. We've got a dog, and then it's got also 4 legs, but different weight. We've got an ostrich and its weight. We've got a kangaroo and its weight, and a chameleon and its weight. And you'll notice that these aren't ordered in any particular way. So if I wanted to do this, if I said db.animals.find, and I want all of them, if I wanted to say, hey, here's how you find the number of, let's go with their weight. So I would say, let's go ahead and sort by the weight of all of these different animals. And I'm not going to write the word ascending or descending. Instead, I'm going to use -1 for descending and +1 for ascending. So if I want to start with the animal with the lowest weight and end with the animal with the highest weight, I would write it like this with a +1 for the weight. And now if I wanted to start with the animal that's the heaviest and move to the lightest, this would be a -1. So let's go ahead and run this. We should see the chameleon up at the top, and then we see the panda at the end, versus if we flip this and run it again, we're going to see the panda at the top and the chameleon at the end. So we can do this by other criteria as well. For example, we could do the number of legs or the name as well. So let's use the name of the animal, or actually let's use what I would really call it. What I would really call it. And so we start out with what I would really call it, Steve. It's in descending order, so Steve is the last alphabetically in this list. Then we've got Scales all the way to Bouncer for the kangaroo at the bottom. So it doesn't, in addition to working for numerical values, it'll also work for strings, and where it will sort them alphabetically as well. Cool. Now, when we get back, we're going to look at how we can connect this to MongoJS, which will be our library for Node that lets us talk to this. We'll have to set up our connections like we were doing previously. It's actually pretty simple relative to some of the stuff we were doing with Sequelize, which is nice. And then we'll also look at how we can just more fully embrace all of the different CRUD operations using JavaScript. And then we'll talk about Mongoose, which is kind of like Sequelize. It's not an ORM, it's an ODM, and it lets us do some of the extra steps here beyond what Mongo has us does, and lets us do things like define models. But we'll talk about all of that when we get back from lunch. We'll see you back here at 12:45. If looking forward to learning more.
Quick request, Eric. Quick
Yes.
request. Would you mind pushing the latest solutions to these activities we covered so far? I need to go back and do some review over at lunchtime.
Sure. Yeah, we'll
Thank
make
you.
sure that those are pushed up.
Excellent.
Cool.
Thank you.
We'll see you all back here at 12:45. Alrighty, folks. It's 12:45, so we're going to go ahead and resume with class. It's actually 12:46, starting a little bit late. But what we want to do next is, this morning we saw a little bit about how to use MongoDB, and now this afternoon we're going to look specifically at how can we connect to it in our JavaScript code. So let's start out in activity 06. If you open up the unsolved version, you'll notice there's a package.json. Let's go ahead and run npm install there, and you'll see that we have Express and MongoJS as our only dependencies. And if we look in our server, we can see some of the standard Express stuff that we're used to saying, like const app equals Express. But we've got some smaller pieces. Let's connect to our database with MongoJS. So our database URL, because it's local, is just zoo. It's going to assume that it's localhost 27107. It's just going to assume that. You can configure it otherwise, but that's our assumption. Next is a list of collections, and this is just to help with the library side of things. MongoDB doesn't need to know ahead of time, but MongoJS likes to, so that I can build those ahead of time. Next, constdb equals MongoJS, our database URL, which again is just zoo, and then the collections that we're going to use. And now we can use this almost like we did beforehand. We're going to add an event listener for errors, just if something goes wrong. We want to make sure that that's working correctly. And so I say app.get / recres res.send hello world, app.get / all db.animals.find, no criteria. This looks very, very similar to what we were doing earlier. The only difference is that MongoJS is callback based. So you pass in a callback as the last parameter for the last thing that you use. If you look in the README, we actually provide what amounts to a seed file for you to use in this particular case. And what we want you to do is create some additional routes. You've got some routes already in place, like all, but you've got two other routes that you need to make. We want you to sort them by the name. We talked about sorting a little bit in the last example. You can consult it there. And by weight. You want to send a JSON response sorted by weight in descending order. So what you're going to be doing is just building two routes. Make sure that you seed your database with this file right here. And when we come back, we'll go over this. We're going to give you all 15 minutes to work on this main task. Just complete those two routes and run them like normal. Once we've done that, we will look at some more CRUD actions and look at this in more depth. If you have questions along the way, let us know. We'd love to help. Good luck. All right, folks. Looks like we're back for the most part. Let's go ahead and look at some of the routes we already have. So if I visit localhost 3000, just says world. And then if I visit, for example, /all. I'll get some JSON. Here's a list of all of my potential animals in my database right now. The names might be a little bit different from what you have, but it should be pretty similar. So what we need to do is implement some extra routes. So let's start with the first one. It's going to be app.get/name, and then we'll take our request and our response. And next, let's sort of copy all. We can see it's db.animals.find, and then the list of criteria, and then sending back, if there's an error, console.log it out. In fact, I'm going to say res.send the error. You should always have a response. Don't ghost your clients. Always send some kind of response back. And so what do we need to change here so that we get the name is the thing that we are sorting by? We still want everything, but we need to be able to sort by the name. So what do we do?
Close brackets after the find, and then .sort, parentheses, and then bracket, and we'll do the quote name, :1.
Yeah, you can leave off the quotes when it's in JavaScript, which is nice. Cool. Anything else?
Yeah, and then that comma, and then that's it.
Right on. So let's check it out. So if this is a 1, that means that we are in ascending order, which means, should I see chameleon first, or should I see, or let's see it based off of the names. Let's look at all. Which one of these should I see first?
Chameleon.
Chameleon. And the last one should be
Panda.
Panda. Whenever you're doing these, it's good to just check the ends, especially when you're sorting things. It can help you figure out, okay, which one should be which. So let's try that out. We put this under the route of name, and so we see chameleon right at the beginning and panda right at the end. Now we also want to do this by weight. Fortunately, this is incredibly similar. Weight, and then what else changes?
We go to -1.
Instead of name, you do weight, -1.
Yeah, not that different. So if we go to weight, / there we go. We'll get our heaviest animal, which happens to be our panda, and our lightest animal, which happens to be the chameleon, but we'll notice that the numbers are sorted in the correct way as well. Cool. Any questions about running this or the server or how we're connecting to MongoJS?
So we, in our group, we had assumed of that putting the .sort at the very end after the last parentheses of find. Is there a reason why your if and else statements and the error data goes within the parentheses of your last kind of function that you want to do?
Yes. So the way MongoJS works is that you can chain certain things together, like finding and sorting. So it might be like db collection, let's say places.find. And then rather than returning a promise, because you want to be able to chain these operators together, as an API, they decided, okay, the final function you call, just add in the callback as a extra argument to it. So if that's find, and find is your last one, then that's where you put the callback. If it's sort, well, then you put the callback after that. So it wants to do all of the other things, and then finally you say at the end, and here's what you do. Now, because these are chained together, they can't return promises per se. So they opted to instead go for callbacks. Now, later, we're going to be introducing Mongoose, which is like SQLize. It's an object document mapper instead of an object relation mapper. And that one will be promised base, and it'll make it a little bit easier. But that's just sort of the design of the library, because they're trying to make it feel very similar to the native MongoDB scripting. They're trying to make it feel very, very similar to it. And that's kind of why you see that choice here, to follow that kind of pattern. Great question, though. All right. Now, for this next exercise, we're going to make sure that we have all of the ability to work with each one of our CRUD actions. MongoJS is named, keeps the same names as the previous one. So you're going to be using insert, you're going to be using find, you're going to be using update, you're going to be using remove. IFER isn't as easy as an acronym to remember as CRUD though, so we'll still keep calling them the CRUD actions, as they're a little bit more universal. Now in this case, you're going to see some extra stuff. So update the server.js files, and you're going to include the following 6 routes. So we've got create with the submit route. You're going to get data from the front end and you want to put it in the back end. You want to retrieve all the notes in the database collection using all. And then you've got another find in there, and then we've got post, and then 2 different deletes. One where we want to delete one item in the collection, and one where we want to delete all of the items in the collection. So if you look here, we've got most of it set up. MongoJS is already set with database URL and a collection of notes. What I would recommend doing is starting with all and submit. Start with these 2. If you've got post working, then you can check in the database that it's making it to the database. And then get all will let you easily pull all of that information out, and then you can keep working with some of the different pieces here. There's notes on how to do each one of those as well. Now, you can see a list of methods that they link here. So if you're curious about MongoJS, we've linked the documentation. If you want to use MongoJS to insert a couple of things, you're going to see some of the problems with using MongoDB, because if you look at a table, you know what data that you need to give to the table. When you look at a collection, you're not necessarily what data you're going to need to give to the collection. So what I would recommend, inside of index.html, you'll see that we link app.js. Inside of app.js, you'll see kind of, hey, what are we sending to the front end or to the back end? Now the front end in this case is done. You don't need to change anything about the front end, but the front end can help give you clues to figuring out, hey, what am I getting? What do I do with the rest of the project, etc. So being able to work within a code base and see how they're doing it in one particular way, still important here. Any questions before we get started? Alrighty, we're going to be working on this for the next 20 minutes. If you have questions, let us know. We'd love to help you out. After that, we'll review it, and then we're going to introduce Mongoose, which will be our ODM, kind of like SQLize, but we wanted to kind of show you that you don't have to use Mongoose, though most of the time throughout the rest of the course, when we use MongoDB, we'll be using Mongoose on top of it. So good luck, and let us know if you have questions. Alrighty, folks. Looks like everyone's piling back in. Let's go ahead and visit our app kind of as is. It's on localhost 3000. And I'm going to keep the inspector tab open at this point. What we're going to notice is that, hey, we're having trouble loading resources. Our all resource just isn't working. So our HTML page is here, and when I try and say like, hey, I want to add in a note and click submit, the submit route is also not found. So I want to build up these different routes as sort of specified in the README for the different pieces. And let's start with post submit. So we'll come up here, up at the top, and we'll see app.post/submit. Now, whenever I have this, something I like to do is just to send back whatever I get. Here you go. This is what you sent me, especially if the front end's already done. Or you can just say res.end, hey, you did it. And you could say console.log rec.body. You can also watch your network requests here and see what we get. So let's wait for it to reconnect. There we go. Let's clear out everything and let's just type in something unique for each. We made a submit request. If we look in our headers and scroll down to the bottom, we can see that we have a field called title, a field called note, and a field called created app. Now, the created app is just a bunch of numbers, and this is Unix time. Does anyone happen to know what Unix time is?
Is it the millisecond since 1970?
It's the millisecond since midnight, January 1st, 1970. Where midnight would be the beginning of January 1st in that particular case. So if 0 in military time, perhaps. I think it's milliseconds. I think you can get different resolutions of it, like microseconds or something like that. But I believe it's just milliseconds in this case. It might be just seconds. I'd have to double check my math. At any rate, these are the pieces of information that I want to store in my database. So to do that, if we look here at the top, we've got a database already in a collection called notes. So to put this information into there, I'm going to say db.notes.what?
Insert.
Insert, and then I can just put the whole thing that I got sent. Now, if there's an error, we're going to need to say, hey, there was an error. We'll send it back. Otherwise, we'll just send back what we got. I forgot this part. There we go. So now we should be able to check stuff in the database. So before I do that, I'm going to see if I have one called note taker here. I do. I'm just going to drop that database. Gone completely. And now I'm going to post something. So I'm going to say, this is my new note. And this is the content of that note. I'm going to click submit. Gives me back a 200. We can even see that it's listed right here. Our get all routes aren't working, so we know that that's the client just saying, hey, we're pretty sure this exists. Great way to check that is you can refresh the page and it won't be listed there because our get all route isn't there yet. But let's verify that our note taker one worked. So let's refresh the page. And we can see here's note taker, collections, notes, and there's my note. So I know my submit route is working. It's putting stuff into the database. The next thing that often you'll work with is read. You often start with create and read, and usually read all, get all of the things that have been submitted. And that's what we're going to do next. So app.get/all. And this is going to be db.notes.what?
Find.
Find. Don't have any criteria, and then we'll take basically the same callback we use here. When if you wanted to be more explicit, you could say res.json data, res.send will look at the type of data that you're giving it and then choose what content type to send it as. So now if I refresh the page, I should see my notes. And if I add another note, this is another note, and it is also super cool. Submit, there it is. Now, if I click on X, it's not working. You can tell that we're using the object ID there when we call delete. If I click delete all notes, those don't work either. Neither can I kind of click on one of these and find out more about it. So I've at least verified that what I'm putting in the database is there, and I can view it again later, but I'm not able to get any of the individual items. I'm not able to update any of these items, etc. So let's go on to the next one. This one is going to be, let's get back information about a specific one. Now, that's because it's another read operation. We can pretty much just copy what we had before and then see, all right, how are we going to modify this? So what's going to be different about this one?
Don't need the app.get.
Oh yeah, lol. So the route will obviously be different. So this will be find /ID, just to match up with what we have written above there. What else is different?
You're going to find one.
Find one. If we checked with our front end, we would see that the front end was not expecting an array back, which makes sense. It's getting something by an ID. There should just be one of those.
And
What else?
then in the curly braces, _ID. And then colon, and it'd be MongoJS dot object ID. And then rec.params dot ID.
Correct. So just like we needed to do this in the Robo3T, where we needed to wrap it in an object ID, we need that here because the string is not the ID. The string is the easy string representation of that ID. It's very easy for us as people to read it, but the actual ID is a little bit more complicated. So we have a function that translates it into that. Cool. So let's check that this works. We can do that by clicking on one of these items, like this is another note, and it loads in the information from those different notes. So we're feeling pretty good about that. Next is update. Again, I like, since some of these are pretty similar to each other, we're just going to say update with the ID. Now, this isn't going to be a GET request. What is it going to be? Now, we might think it would be put, right? Since it's update, but we're using post. And that's just because it's specified here in the documentation. If I was writing this myself, sure, I would want to do put, but again, it's not a law that we have to use put for any of that. Is it more semantic? Does it follow the standards better? Yeah, but there's plenty of ones that don't do that. You'll notice that we're also not using /API in front of all of this stuff. There's plenty of APIs out there that don't follow the standard. So when you're making your own, it's good to have a standard that you work from so that you kind of know what to work with, but there's plenty of APIs that don't follow these standards. And this is an example of that. So it won't be db.notes.find1, it'll be what?
It's update.
Update. Now we can keep this part the same because we're still finding an object based off of its ID, but we also need a second part. And what's that second part going to be?
Set to rec body.
So we'll say $set, and then all of the different attributes. Now, if we look at update, if I click update here, you'll notice that I'm just sending the title and the note, so it doesn't have all the parameters I want. So I'll need those pieces, that's for sure. So I'll say title is rec.body.title, note is rec.body.note. But when it's modified, or when it's created, we're going to say date.now. And date.now is going to return it in that Unix time. So that's not something we're getting from the front end. We're recording that ourselves so that no matter what time zone the user is in, we sort of have a consistent time frame from the server point of view about when different things happen. Cool. And then the error data stuff is the same. But let's check to make sure that it works. So let's click on this. This one has now been modified. Let's go ahead and click update. Let's even try this as my new note and say changed title, click update. And if we refresh the page even, we can see that the two different aspects of it have been changed. Cool. Last one we need, again, we are going to just copy and paste from before. Since this is uniquely identifying one of them, let's go ahead and keep the delete there. Oh, need to copy over the whole thing. Except we're going to say app.delete. And of course, this changes to be delete. And unfortunately, it's nothing as satisfying to say as destroy. What is it?
Remove.
Yep. Do I need to change anything else? No, that's kind of it, right? So next, I want to delete not just one, but all of them. So what's that going to look like?
Is it the same thing, but you don't have the ID part?
Yep. That gets rid of all of it. And of course, we need to change the URL, but other than that, it's pretty much the same. Now, in real world applications, things would often have a little bit more to them. We saw already with Project 2 that oftentimes things belong to users and we don't want other users to delete them. So in the real world, you would have some more complicated logic like, hey, does this belong to this particular user? Does this user have the capability or the permissions? Is this user authorized to do this kind of thing, etc. And so these are kind of simplified from real world versions, but they illustrate the point of all of these different CRUD actions. Any questions? Alrighty. So last thing I want to talk about today is something called Mongoose, and we'll be looking at it more tomorrow as well. So if we were to make a spectrum, let's say, and on one side, and we labeled this spectrum very structured on one end, and then very freeform on the other, we'd see MySQL probably around here of the database technologies we've learned. Very structured. You have to set everything up properly on one end. MongoDB is probably over here. So my next question is, where do you think MySQL with SQLize is on here?
Halfway,
It's
further, way out there.
it's even further to the right, right? It's even more structured than that because we've got our validation rules, we've got all of the other stuff. It's even more structured. So adding in an ORM moved this sort of further to the right. We've got more structure around it. So and that's by adding in an ORM. Now, because this isn't a relational database, we don't have an object relation mapper. This is a data database, so we have an object, or a document-based database, so we have an object document mapper. And which way do you think that brings us? Further to the right. So sometimes we like being freeform. We can put just about anything we want in there, but it can also be hard to reason about. Hold on. Someone must have dropped off a package at the door or something. So this is where we're going to be with Mongoose. It's still a little bit more freeform than the rest of this. By the way, this middle section, not necessarily to scale. I don't have a big wasteland in between the two of them. It just helps emphasize the point. This is going to allow us to specify certain things like validation rules and even what our collections should look like. So between Mongoose and SQLize, the code will actually look similar, but we can set it up to be a little bit more permissive, and we still have some of the freedom of structure here, like being able to embed arrays into other pieces. So we're still more freeform than what you're going to see over here. You're still more freeform, but you've definitely got more structure than you do with Mongoose. So we're going to be adding more structure to MongoDB. Now, sometimes you want that structure, and other times you might not. In our case, we're at least going to give you the capabilities of doing that. So that's kind of a little illustration for where we're going next. So we're going to jump straight into the Mongoose schema. So schema tells you, hey, we're defining a little bit more about it than before. So here's our server. Instead of using the MongoJS package, we're just going to use Mongoose. Mongoose has its own driver, and unlike SQLize, we don't need to have like how SQLize has a MySQL 2 package that it needs to have as well. Mongoose handles all of that itself, so we don't need any packages besides Mongoose. And then Morgan is just a logging piece of software. It's just to help us log stuff. It's not going to functionally do much to our data. It's just going to help us see things a little bit easier. So inside of our server, we're going to do a couple of different things. So, and server is a little bit of a misnomer because we're not really doing much with Express here in this case. So if you look in package.json, we have Express. We're not really using it yet. You could imagine how you would. Let's start out with just Mongoose by itself. So we start out, we require Mongoose. Next, we have a model to Mongoose. We'll look at that in a little bit. We have mongoose.connect. This is going to connect on localhost on the default port, which is 27107, I believe. And then it's going to connect to our DB example database. This is our data. we have an array, a Boolean, a string, a number, typical MongoDB type data. Not something that would easily fit in SQLize, for example, because it can't handle the array very well. And we say example.create data, and then, so we see it uses promises, we'll just console.log out the result. So let's do that real quick. So I'm going to say node, or let's cd over into that one. Make sure we have all the pieces. And let's go node server.js. What does it do? Is it just puts a piece of information in there. Now let's come over here and let's clear that out. We can tell that this one is the DB example. So let's find that one and let's drop the database and just restart my server real quick. So now, if I come over to that database and see my list of examples, it has the information. It has the 3 elements, it has a Boolean, it has a string, it has a number, and it kind of tells us, hey, that all worked fine, no worries. But if I run it again, we're actually going to see an issue. And it says, hey, duplicate key error, collection db example.examples index. And it's a big complicated error message, but we'll see that it failed. It didn't allow us to insert another item into there. And that's not something we had seen before. We had seen before that we could just insert things with the same properties because it didn't care. Because MongoJS is like, sure, whatever, just put a document in here. I don't mind. So let's look at the model and some of the restrictions, some of the structure that we've added to this to make that happen. So the first thing is we have the name of the field. The name of the field in this case is helpfully enough string, not confusing at all, right? But this is of type string. And you'll notice we're not importing this from anywhere. There's no data types.string. This is just string. This is actually, if you come into JavaScript, this is just a native function on there. It happens to be the string prototype from which all other strings are made. So you don't need to import anything for this type. Same thing with number or Boolean. These things just exist in JavaScript. So rather than saying something like data types.string, Mongoose has elected to just use the native types that are built in because it's mimicking JSON. So it just leverages that. So we can see a couple of extra pieces on here. One, trim is set to true. So whenever we put a string in here, it's going to trim the edges. This string is required. You have to have this string. Now for the number, we have the type number. It's also required, and we see a new parameter on here, unique. Within this collection, this value must be unique. That's what we're communicating here. Now there's some asterisks to that, but that's what we're going to use it for right now. The email is a type string, and we have validation here, similar to what we did with when we did SQLize. This is just a regular expression that says it has to be an email address. So it says this is something at something dot something end of the regular expression. Boolean, you'll notice here we don't have any extra information, so we're just saying, hey, this is a Boolean. And the same way that we could do that with data types without putting more information around it, you can just specify this. But we can do some stuff that we can't do. Like we could say, hey, I have an array. And guess what? It's an array. You can just have arrays of stuff. Now these are not required. These are optional. Unlike SQLize, when we look at this, it won't necessarily have a field set to null. We just won't have it if you try and submit an array there. So it's still a little bit less structured than that. We see a date, the type is date, the default is right now, and this isn't a value, this is a function to run when you need it. So another way of writing this might be something like this. So whenever it needs a default value for date, it just runs this function, which in this case is date.now. You can even do validations like long string. I want to get the length of that string and make sure that the length is greater than or equal to 6. And if it's not long enough, it'll reject it. So let's put this to one side and look at some of the validations that are going to be different. So first of all, let's go ahead and pause this real quick. We already have a 42 in the database, so we need to change the number to be 43. Can I take out the array and not include it in my list?
Yes.
Yeah, it's not required. So let's try that. So let's run this. And you'll notice it very happily said, yeah, you inserted it. And if we take a look here, in this particular collection, we can see there it is. And it's got array with no elements. So it just said, okay, I'm going to make one for you that's empty in that particular case. So it helps keep it a little bit more consistent. Let's look at the date. In this case, we don't specify a date, and you'll see that it's different from the time we specified earlier. So the date is a little bit different. We didn't just hard code it to be one date. These dates are a little bit different. Let's see, what else do we want to work with? Let's try putting in a long string, and we'll change the number to be 44. Long string, and let's just set it to be ASDF, which is not a particularly long string. We already have that in the database. I need to save it. Let's run that. There we go. And so now if we look at our list of examples again, the long string. Did I save it? Oh, okay. So this is an example of where it can sometimes bite you. What's different between these two?
Minimum of 6.
Well,
Oh,
technically,
casing.
the casing, right? So the casing got us. So it's like, sure, you gave me some extra thing I'm not going to do anything with. I'm not going to put it in the database. So you'll see here, there is no long string piece. So even if I passed it an object with extra pieces, even ones that are very close to what I actually want to set, it's like, yeah, sure. And then just doesn't put that information in the database. So this is where Mongoose can be a little, where you can see even some of the free-form nature of it is a little off, which is why we tend to mark things as required. If I set this to be required, then if I didn't provide a long string, or I provided a long string incorrectly, it would throw an error. But because it's not that way, it's not going to throw me an error. It's just going to be like, all right, you gave me some weird extra property, you dingus, you know. So that kind of highlights some of the differences. I'll need to bump up the number.
Because it's less than those 6 digits, it won't add either.
Right. So you'll notice this validation error.
Oh, I see.
Long string should be longer. So if you mess up the property name, obviously it doesn't trigger the validation for that field. Cool. So that tells us a little bit about Mongoose. So we can provide a little bit more structure. We can describe what it should look like a little bit more by using this model. And you'll notice we just have it right here, and then we run it. And we make it, we say const example equals mongoose.model example. Following a similar convention, you'll see that this is labeled examples because in our database collections, we pluralize things. But that's based off of the name example right here. So if I change this to be what about a bing bong, I'll get what about a bing bongs, I think is the plural. and the validation still failed on there. So let's add in some other ones. Start it back up again. And so now if we look in our list of collections here, let's refresh everything real quick. You'll see that we have what about a bing bongs, the plural version of it. I don't on there. So that's the list. I don't know how good it is. I haven't tried like octopus or anything. In fact, let's try that. Let's see if it's smart enough to figure that out for us. Always curious about that. So let's refresh. And what do you know? It does know the proper one on that. I bet someone put a little bug issue on GitHub. They're like, this isn't correct. And then they fixed it. So again, it's just going to be the plural form of whatever that is. The model is the octopus model. It's the singular noun version of it. The collection is octopi, the collective one of it. Cool. So that's a little bit of an intro to how models work. Now, we want you to practice making a model of your own. So we're going to have you make a user model. You had a user model from us last time for project 2, and you can see already that those are pretty common and useful and going to turn up in a lot of different places. Let's close all of those pieces we're not using. We can view all of this at once. Actually, I'll just bring this over here. How's that, those? That's the wrong one. So close. There we go. So our user model is going to have the following fields: username, password, email, and user created. So the username is going to be a string, but we're going to trim it. The password, I know it says trimmed there. Don't trim passwords. Just don't do it. If people want to have 5 spaces be their password, they get to do that. So I'm going to drop that requirement on there, but it should be at least 6 characters. The email should be a string that has to be a valid email address. You can actually look at one of the examples we had earlier for what things or what an email address looks like. And it has to be unique to our collection. So both unique and has to be an email address. And then the user created is a date that will default to the current date. You'll again see that in the example model as well. So if you want the regex or the regex, however you want to say it, for checking if a string is an email, there's it. If you finish early, you can look at inserting a bunch of documents once, just like you can do insert many. There is something similar in the Mongoose documentation. We'll be slacking out a link to that as well, but you should be able to do this activity with just the previous example. In the unsolved folder, we've got a server.js, and the server.js works, except that the user model isn't defined yet. What we want you to do is make sure that you've defined all the fields of the user model appropriately, then you can try and run it, and your application should work for making and looking at users. We're going to work on this for the next 15 minutes, and then we're going to review it, going a little bit into office hours on that, and then tomorrow we will continue looking at Mongoose in more detail. But if you have any questions, let us know. We'd love to help you out. Good luck. Alrighty, folks. So let's go through and I'll start by listing some of the requirements. So we had a username. We wanted it to be a string. We wanted to trim the edges, and we wanted it to be required. For the password, the instruction said trim. I'm going to nix that one. We also want it to be required, and we also want it to be at least 6 characters. And then we wanted an email. We wanted it to be a string. We wanted it to be unique, and we wanted it to match the email regular expression. And then lastly, we wanted to have user created, which was going to be a date, and default to the current time. Fun. So let's go ahead and start out with the username. What goes in here?
Type :string.
Type :string. What else?
We put in a unique :true.
Well, the username on this point, technically we don't require a unique. Now, very common to do that, but technically that's not mandatory.
Trim
Required true.
Untrue.
Trim true, required true. So unique, technically not there. Now, if you were making this model, you probably would do that. A lot of people do, but technically not part of our requirements. All right, next up we've got password. And in fact, it starts out being pretty similar here. So I'm going to copy this over. We did not have the trim requirement, but we did have the length had to be at least 6 characters. So what do we do?
Validate.
Validate.
And then an array. Or start opening an array. And then in parentheses. And then an object. It says length.
Length. Yeah, this is just restructuring. You can also just take like, you could say like PW. PW.length is greater than or equal to 6. So the first one of these is the function, and then the next one after it is the message in response to it. So password should be longer than 6. It should be longer, or let's be more specific. Should be at least 6 characters. Cool. We also need an email. It's going to be a type.
String.
What else?
Unique true. And then match the regex expression.
Match. We'll put the regex expression in just a second, and then we'll say, please enter a valid email address. I might argue that we should put trim on this too, but it's not required. So for the match, it's slash and then something and then another slash, and this is our regular expression. So dot represents anything. The plus represents at least one of. Then we're going to put the literal at symbol. Then we're going to say we can also do a bunch of other stuff with another dot plus. And then we're going to need a literal dot. Now, because we can't just put dot there because that means something else, we have to put a backslash in front of it to escape that. And then we're going to do another dot plus for the last bit of it. That's an email address. Something at something dot something. Now, there might be more restrictions that you might put on that in the future, but that's that one. Last one. User created. What's the type?
Date.
And the default?
Date.now.
Date.now. And remember, date.now is a function. When you do the default, you can either provide a value for it or you can provide it a function to call. So if I said date.now, when the model got created, that's when everyone would mark the user created at. So we don't want that. We want this. Cool. Let's test to make sure that it works. And then we will be done for today. So we're on localhost 3000, ASDF, ASDF, ASDF. Should get some validation errors. I click submit. Here's a list of my problems. One, the password was not long enough. The password should be at least 6 characters. Another one, it was not a valid email address, as ASDF isn't. So overall, my user validation failed, and we have these nice user presentable messages to give to them as well. That's a nice thing about Mongoose. Let's correct that. So let's say ASDF, the password is the much more secure ASDF ASDF, and the email is asdf@asdf.asdf. Let's click submit, and it's like, yeah, sure, that's fine. That meets all of the requirements. And you'll notice the user created, though it was not provided, matches up with now, and then we've got that underscore ID, and then we've also got the specific version we're working with of the model as well. Cool. That's all we got for today. Tomorrow, we'll do a little bit more with Mongoose. We'll look at custom methods as well as how we can relate collections to each other, doing something like joins with the populate method. And then we're going to talk about moving away from server-side storage to client-side storage and talk about something called indexed DB, which is something that exists in your browser. So we're going to be heading back to the browser tomorrow for a bit. And then we're going to be looking at how we can enter the wide world of progressive web applications, or web applications that you can install on your machine, which is pretty cool. Any app that has offline capabilities, or it's websites with offline capabilities that you can just use, which is kind of neat. But that's tomorrow. We're going to get office hours started in just a little bit. We'll have the one-on-ones. I don't have anything in particular prepared, so if you've got questions about MongoJS or Mongoose or anything else, we'll be kicking that off in like 2 minutes or so. If you're headed out at this point, it was great having you in class. If you're staying with us too. And we will see you in about 2 minutes. Have a good evening. All righty. Welcome back, everyone. First of all, I want to just open up the floor for any questions on MongoJS or Mongoose, or any questions about maybe you have leftover from project 2, etc. So I just wanted to open it up to begin with that. All right. Doesn't seem to be any particular questions at the moment. So I'm just going to open it up to be a little bit more generic if anyone has anything at this point. Otherwise, I don't know. We'll figure something out to look at.
Yeah, Eric. So what was
Yes.
your opinion yesterday? Like you on all of our presentations, like how would you grade us? Like, based on the amount of time that we've had being exposed to this technology, how did we do?
I think as a cohort, y'all did pretty well. Can't discuss individual grades, as those will be given out.
But in general, for the entire class.
I think you did pretty good as a class. Overall, it was pretty good. It's always good to see everybody deployed. It's always good to see, like, hey, we expanded on the foundations a little bit. So overall, I was pretty pleased with it. Just to sort of give it a broad overview. As a class, we're still working on getting the grades in for those, but I was pretty pleased with how everyone did.
How about security? Doing this NPM install, I'm just like, every time I'm seeing files being downloaded on my computer, like, have you ever had any issues like with you getting viruses or something malicious on your computer? Like, do you have any like?
I haven't. It's possible to do it, obviously, because you're just grabbing files from somewhere else. NPM audit is generally pretty good at catching one of those, but that is one of the criticisms of NPM, is how open it is and how much people can kind of put whatever they want on there. Most of the way that people get around that is by just working with reputable packages. They're not grabbing stuff that's like a no name. But there was an interesting incident, not necessarily a virus, but if you look up npm left pad incident, you'll hear a little bit about this historically. So it's an interesting story. It's back from like 2016. How one programmer broke the internet by deleting a tiny piece of code. So a programmer wrote this as a module. It's called left pad. And what does it do? It just puts some extra space on the left of stuff. And so and this is nothing you couldn't copy and paste and put in the code yourself. But this guy sort of took it off the internet. He made it public, and then a bunch of people developed dependencies on it. And it was part of their dependencies for just a whole bunch of different stuff. And then what they do is the guy deletes this npm package called leftpad, and now it's not in the registry, and now people can't build their packages because one of their dependencies are missing and they're not exactly sure why. And then things like React get affected by this, like not insignificant web things and things that a lot of people use. So if you want to learn more about that, that's kind of interesting. And then people basically forced left pad back up again at some point. But that's one of the criticisms of npm, is that kind of stuff, and especially how centralized a lot of those things are. There's a project out there by the creator of Node. He made a new project called Deno, definitely not Node. And his is a little bit of a departure from that. It's still a JavaScript runtime, but it's trying to fix some of this stuff, but this is much newer. And it's supposed to have better security. It's supposed to support TypeScript, which is a language that's like JavaScript and then some on top of it. And it makes it the way that you work with third-party modules. And Deno is basically you point to a GitHub repo. You're like, there it is. You can use that one if you want to. So it's a little bit less decentralized and other stuff like that. So if you're ever interested in that kind of stuff after the course, that's another thing to look at, stuff like that. But this doesn't have near the market penetration, let's say, that Node does. So it's also not nearly as finished, let's say. This came out, I want to say like 2019, 2018, something like that. So it's much, much younger than Node, which came out, I think, in 2009, 2010. It's a whole bunch of fun stuff out there. Another thing to learn if you're like potentially after the course would be TypeScript. TypeScript is what is called a strict superset of JavaScript, which means all that the JavaScript code that you write is technically valid TypeScript as well. And it is interesting because you can add in types. You can say like, hey, I want this thing to match, the same way that you can make that we have schemas for models in the database. They do that same, they take that same idea and apply it to functions and objects, and everything has to match schemes, as it were. And you'll have errors if you don't match things properly. So this is made by Microsoft. A lot of people really like it. And it's worth potentially looking at in the future. It's got some intros to it, and people like it because it's harder to make certain mistakes by accident, among other reasons. But so you could say like, oh look, this is done is a Boolean, this decimal is a number, this string is a string. And right at the beginning, you're like, that seems kind of obvious. But it's really nice to know that the thing that you're being given is a string and not a number when, say, for example, you're adding them together. right? So if you're adding together two numbers, you're expecting to get another number. But if you pass in a string by accident, you can run into problems. In fact, I know that there's some people that throughout the course that I've taught have had that exact problem pop up, especially in JavaScript, where it's like, oh, I thought this was a number, turns out it was a string, or vice versa. So that would be another cool thing to learn, but again, that's outside of the scope of this class. If I'm just pointing at things outside of the class and go, that's cool, that's cool, that's cool. Those are some of the things.
Maybe after the boot camp is over, I'll go look into it.
Yeah.
But no, thank you very much.
That's how often I feel like with a lot of stuff where I'm like, this would be fantastic for you to look at when you have the time, which is not right now.
Eric, I got a couple random questions.
Sure.
Do we, when we start making all the repos for the rest of our homeworks for the remainder of class, do we have to include the linter, or was that just for project 2?
That was just for project 2. You don't have to include a linter if you don't want to. It's not bad. It can be nice, but you don't have to.
Gotcha. And also, this is more random, but I've been seeing these ads for this website called Webflow. Have you heard of this? That like allows you to like build websites with backend stuff like, I don't know, like attached to it. Do you know anything about this? Have you heard about this, or like, is this like a thing? They're saying it can like replace, like, you can build out websites without, you know, needing a programmer or code. Like, it seems kind of gimmicky, but I don't know, like, if it's legit.
Well, it's the same way that you can build out a WordPress site without necessarily needing a developer. Is kind of how I view it. It's an evolution on that. Like, it's not going to replace the need for front-end web developers, but it just means that there's more powerful stuff that other people can do. So if you look, I've heard about it. I haven't used it a ton myself. When I talk about the UI UX classes, it's good for that. And it's fine for a lot for what I would call static pages or poster websites where you're just kind of looking at it. But if you've got any kind of complex interactivity going on with it, a lot of times these things aren't as good for that. So you can see that I tried this out and then was like, eh.
Yeah, I just kind of wanted the opinion of like a real developer to see if it was like, you know, a legit thing worth looking
Sure.
at, you know.
Like, you can look at it and you could work with it and try it out, but like it's a real thing. Designers use it a lot. So it's like, hey, let me try and build these different pieces, build something with it. I'm comfortable enough with code that I would rather just use code 90% of the time, but that's obviously not me, or I'm not the average person that this is aimed at as much, let's say.
You said
you can pick different things, and it helps to know, like, hey, what are margins? What is padding? Know all those developer concepts going on beneath it. What are the property names of the CSS I'm actually working with? So even if you want to do some of this stuff and like mess around with it, it'd be like, hey, I'd like to move things, do all this visually. I feel comfortable enough doing that with the inspector that it's not much of an issue for me, but it's all stuff you could do.
Yeah. It looks like it can help you visualize, you know, kind of everything that's going on. You said WordPress works the same way. I've heard a lot about WordPress and it seems like a really popular thing, but I haven't had time to really look at it.
Yeah, it's a CMS. It's based in PHP and there's a lot of plugins and different stuff for it. It's just a platform.
Gotcha.
That for like making blogs and stuff. Just the same way that you would have any template site that can manage that for you.
Gotcha.
So it just depends on how custom oftentimes the stuff you need to do is. And sometimes you can get away with like a template that you copy paste the correct information into and you're like, it's good enough. And you might not say, I need a programmer for that. But as you get into more complex interactions, you tend to start going, what if I had a person for this?
Yeah, totally. I get you. Right on, I appreciate it.
Yeah, no problem. Yeah, the tools will always get better. There'll always be new tools, but there's also always going to be the people that use those tools, and someone who's like, it is your responsibility to make sure that with these tools, the thing that we want happens.
Yeah, happens. Gotcha.
But it's worth knowing. It's not bad to know. It wouldn't be a waste of time if that's what you're worried about. Depending on what kind of work you want to do. If you want to be more front end and work with designs and things like that, sure. If you're saying, I would really like to work a lot with databases and big data and stuff like that, then you still might use it for something like visualization, but it might not be as high a priority for you. Just depends on what you want to do. It's a tool. Yeah, it's just like hammers. No one uses hammers anymore. It's all about screwdrivers now. It's like,
It all depends on the scenario. And the
Mhm.
situation. Yeah.
but when they come out with new hammers, I'll admit, I'll be like, ooh, that's a new hammer. Wonder what I could do with this hammer. Another one out there that would probably be good to look at is GraphQL. GraphQL is a little bit different than RESTful web services because all about retrieving information in a particular way. So in the same way that you might describe the data that you want in a SQL query or something like that, you can now do that, except you're talking to someone's API. Now their API has to support it, but then you can pull out information in a way that you want in particular. So you don't have to string quite as many requests together. That's another thing that's getting more and more popular. For example, the GitHub has as part of its API has a GraphQL implementation of it, but you can ask for the pieces of something that you need and just the pieces of something that you need, kind of like an example here based off of that, so that you're not making like 4 different requests and then stringing the pieces together. And they've got a lot of cool tooling that works with that as well. So if you're interested in APIs and working on that side of thing, GraphQL is another cool thing to look at.
I have a question on HTML routing. So
Sure.
for our website, we when you come to the index page, it's just the index page. And then if you click on one of the sections that requires a login, it takes you to the login, or you can click sign up from there. But so like as a user, if I'm just on the home page and I click buy and it takes me to the login page, how do I get it to get me to the buy page after that click?
Oftentimes you'll just store that in like local storage, or they'll issue you a cookie just as you sign in, or like once you're there, and they'll just be like, hey, here's a visitor cookie so that we can track this person across the website. So you don't need to be logged in to have a cookie that marks you, because they'll just issue it to your browser as soon as they see you the first time. And that's why a ton of sites are like, even if you don't like have an account there, they'll be like, hey, we use cookies, could you accept us using cookies, because they're marking you as soon as they see you.
Got it. And that's something we haven't really
Not really. It's not that much different. Like it's not too hard to put tracking cookies on people. Just not. Most of even then you could store some of that in local storage. Like, hey, here's your shopping cart. This is the items that you were looking at, and then we'll pull it back out of local storage or something like that. But more often than not, they would probably just have a little tracking cookie on you so that they could keep track of it. So they're keeping it in like a temporary section on their backend that's not tied to a specific user. It's tied to this transient account. And most of the time, also a lot of those applications are single page applications. So even if it looks like it's changing the page, it's not really. So it's holding on to the data the whole time.
Gotcha. So it's like just bringing up new HTML depending on what you.
All right,
The
and we'll
Mon-
see that when we get to React and do client-side rendering and all that kind of stuff. Very
Gotcha.
similar
Thank you.
to the server-side rendering we did. The syntax is just a little different, and it's being done in the browser instead of on your server. But that's a way. There's plenty of ways. But yeah, it's always fun to have like a pop-up blocker installed and just like look at how many things are looking at you visiting a website. And you're like, I'm not even logged in, and all these people are trying to see what I'm up to. And there's always the fight between you keeping your privacy and still using the site, or blocking ads and people trying to get around that. And you're like, oh, I have an ad blocker, and then the ad blocker fighter is loaded and they're just duking it out in the JavaScript. You're like, cool.
I'm checking out. You all have a great evening.
Have a good one, Walter.
All right.
I had a quick question about MongoDB. So
Sure.
does it not require like configuration since there's not a password or anything?
Right. It's using the defaults. The defaults are a little bit more set up for it, especially when you're working with it on your local host. When it's, for example, when you deploy it, there will be a configuration section where it has like a username and a password associated with it. But basically you just have the defaults running on your machine. And because we installed everything with all the defaults and the libraries know the default, we don't need to configure that stuff.
Okay, so whenever we deploy it on Heroku, do we need to do like config bars on that?
It'll be similar to that, but just like you had the JAWS DB URL that got set up, you'll essentially just have one for MongoDB.
Okay.
And it'll say like, hey, here's the connection string, and Mongoose will know how to connect to it, to that. So you won't need to set up too much of that yourself. Also for project 3, you don't need to use Mongoose and MongoDB. If you don't want to, you can just keep using MySQL. But it's not that different. Especially once you put Mongoose on top of it, like the SQL, it feels a lot like SQLize. The syntax is just a little different.
What's more of like the industry standard, to use Mongo or to use MySQL?
Depends. Depends on what you're doing. They're both popular, so you'll probably run into, like, depending on where you work, yeah, you'll have a pretty good chance of running into both. MySQL's older and therefore more established, but a lot of people also like doing stuff with Mongo because of some of the benefits that it provides. Most of the time, if you are at the level you're at, you can just work with it and sort of figure it out and get better with it. And so I wouldn't say I know one is like, you should definitely pick this one over this one. Like, they're both good to know. Usually just depends on the kind of data you're working with. And there's other databases out there, like there's Cassandra, there's stuff where everything's stored in memory, like Redis, where it's just a bunch of key value stores. There's a whole bunch of ways to persist or work with data in the long term. I would say just pick one and get pretty good with it. And then if you're like, yeah, I know MySQL pretty well, they're like, that's fine. You know a database, that's fine. You can learn the other one without too much trouble, especially as a junior developer. Now, if they're hiring someone, they're like, we need to optimize queries for our MongoDB database, then it's like, maybe that's not a junior position, so it's fine. I would say overall, it's probably trending more towards NoSQL as opposed to SQL, but SQL still definitely has its uses. SQL used to just be the only game in town. And now there's alternatives. And there's even graph databases, which are fun. So like Facebook has one, I forget the name of it, but it's like for tracing your friend graph. Like LinkedIn has a feature like that for seeing like when you see like, hey, this is you're a third degree connection to this person. Like it excels at working with those kind of structures and those kind of questions with how are things connected to each other, especially through intermediaries.
What kind of databases does like LinkedIn or Facebook use?
Well, let's look, right? LinkedIn databases. Let's see. A lot of times you'll run into developers essentially talking about how they did stuff. They just had a good old database. They had a member graph. They probably have a custom DB in this case, because turns out it's just software, you can just write it. But I think like Facebook started out just being like PHP and MySQL.
Okay.
And then it changed as it grew.
Whenever we were doing our project, we like really wanted to include a profile picture, and like that would have involved storing the image in MySQL, which is where we kept getting kind of that like answer that wasn't a good idea to do. And so I was curious about what they were using to store their images.
So usually what you do at that point is what's stored in your database is a URL of where to find it, and then they have internal hosting for that. So they would have like a very common provider of this kind of stuff is like Amazon S3. Where it's essentially a place where you can store files. You can think of it like a big bucket where you can store a bunch of files. And a lot of people don't necessarily implement that themselves because the web server shouldn't be worried about all these external files. So when you talk to your web server, let's mark out a couple of different boxes for this. So there's your web server, there's the browser, and we'll put the database somewhere over here. So let's label all of these. The database, the browser, and the web server. So the user wants to upload a custom image file. So the browser takes that information and it says, hey, web server, here's all that data. Here's my profile and here's my profile image. I'm uploading a thing. Now, what you could do is you could say, web server, especially if you have more control over your web server than we do with Heroku, you could say, just store this somewhere on your computer. You've got a file system, store it somewhere. Now, the thing about Heroku is that it doesn't really give you persistent storage because it's kind of just spinning up a computer whenever you need to run this part of the program. So what you want to do is you want to have a better place to store that. And when you have structured data that's just relatively small, finite bits of it, then that works because we're storing things like numbers, Booleans, and those are pretty small. And then you've got your, 2 gigabyte background that is going to destroy your connection or something like that. Let's even say like you've just got 10 megabytes of data, like a 10 megabyte background. Most of the time, you don't actually want to store this here, especially if it's something that the user put up there. If it's just part of your website, sure. Like if it's like a banner image, it's just always there, sure, put it on the website. Everyone's going to need it all the time, might as well put it there. But the user's uploading something, and so we don't want to store that on our web server, and the database isn't really a great place either for it. So we've got a service like Amazon S3 that stores these files really easily for us. So what we do is when they give us the data is we say, we're going to put that data over here. And then S3 is going to give us back an ID where we can get it back, or a URL where we can get it back. And that's what we store in the database. And the nice thing about Amazon S3 is it's really easy to administer what's in there as well. So you can be like, oh, that's not an image I want associated with my website. Get rid of it or replace it with something else, for example. And now your database isn't worried about being a file store. And so you can treat this more like a CDN that just happens to have all of that stuff for you. But the thing is that you have control over that specific, what's often called a bucket. It's called a bucket because it's just a place to store a bunch of stuff. Static files like that. And the nice thing about Amazon S3, or you could even use things like CloudFront, is if I'm traveling all over the world, let's clear this all out. Here's the Earth, round. We're over here in North America, and then let's say we've got Europe and Africa. I'm going to try and draw that a little bit better. There we go. You can kind of get what I'm going for at any rate. So our web servers are right here, right? That's our web servers. And we've got them. We're like, okay, cool. Now if our images are here too, and someone over in Europe asks for that, they have to go all this distance. And distance, even now, is still time. And we don't want it to take a lot of time to load all of that information. So we're sending it over, we're getting it all back, that takes time. Instead, wouldn't it be nice if we just had different spots around the world with copies of all of this stuff? So you've got a copy of some of the data over here, and you've got a copy, and you've got a copy. So you're still talking to me for maybe my data, but if it's just static files, I can go talk to you and bring it back. Netflix does this. Netflix has, for their movies, they just have a bunch of places nearby where they have a bunch of copies of all the movies ready for you to use. It's really funny too, because it turns out that whenever they make a new one of these sites, including this one that's apparently out in the middle of the ocean, what they do is it's way better to use what we like to call sneakernet. Does anyone know what sneakernet is? Than the internet to get it there. Sneakernet is when you load a bunch of hard drives into a truck and drive it over there. Because the data transfer speeds of just grabbing a hard drive and copying it all over there rather than sending it through the internet is much faster. So when it's always fun to be like, you know what, we could just send, Jack or Jane or Jill or whoever with a bunch of hard drives over to the other location rather than trying to get a bunch of extra stuff. So our good old George just goes over here and he's got a big suitcase full of hard drives full of movies when they're spinning up a new one of these nodes, and they just plug it all in, which is fun. And we like to call that sneaker net because it's just someone walks over there with everything. Of course, walking is a little bit different, but that kind of gives you an idea of what you do with the images is you hand them off to somebody else, and those people tend to provide it for you. Now, could you do it on your own? Yeah, you could, but I would say it would be better to integrate with a cloud service for most of that, rather than trying to put it all on your own website, especially if you're taking images from John Q user, rather than like an operator of the site, essentially. Does that answer your question? Kind of went off on a tangent.
No, it's really interesting. So is that kind of what like AWS does? Is it like provides a service to house all of the information like that?
So yeah, so here's the US, beautiful, I know, right? And here's Florida just sort of hanging out at the end. You've got AWS East. That's one of the spots where you can have one, and it makes it really easy to talk to the East Coast and other stuff like there. You might have AWS West or all of these other locations. And these are just spots where Amazon Web Services are because they want to be close to whatever's going on. So Heroku is built on top of AWS, actually. So what they've done is they've simplified the process of there's a bunch of servers in here, there's a bunch of servers in here, there's a bunch of servers in here. And what they do is with Heroku, with your free tier, they, at any given time, Heroku has a set number of kind of computers that they're renting. And this would dive into virtualization. Basically, there's the physical hardware that runs everything. And then sitting on top of that, we've got what you might think of as virtual machines. And these tell any software running on them, hey, I'm the computer, talk to me. And then this virtualization is there. And as it turns out, we could scale up more or less of these pretty easily, keep these separated from each other. So it looks like to Jim or Jane or Jill that they've each got their own machine they're working with, even though they're all just sharing one piece of physical hardware. So one big computer pretends to be one super awesome computer, or a series of super awesome computers pretend to be a lot of crappy computers, is essentially what's going on there, or a lot of crappier computers, let's say. And so what we do when we deploy to Heroku is we say, hey, I would like a crappy computer to run my machine on. And so they just, the term is spin up another one of these, and they put it on the big list of physical hardware. They download your program onto it, and they start running it, and then they start listening for network traffic and responding back. And that's what your web server is. Now, you could do other services on top of this, like file storage. That's what S3 is doing, where it's got big ol' hard drive or a virtual hard drive, whether that's done in RAM disk or something like that. And it says, all right, this piece is your bucket, 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 and lets you use that. Lets you use a piece of their massive hard drive. And it says, hey, you can use this. We'll hold on to it for you. And that's kind of what S3 is doing. And so without getting too much into the weeds of it, like there's a lot of complicated stuff going on beneath the surface for me to be like, oh, I deployed my website and now it's running on there. Because when a request comes into Heroku, the first thing that it does is it says, okay, do we have a VM that's already running this? We don't, because they're on the free tier, and of course we don't. All right, let's load in their application, install everything, make sure it's started up, make sure it's booted correctly. And okay, now we'll respond now that we've got everything done. So that's why your first hit to Heroku takes a while. It's because the process isn't actively running the whole time. They wait for a request to hit the service. They check if that program is running or not. If it is, they just keep using it. And if it's not, they have to make a new virtual machine and put it on there. Short answer is the cloud is crazy. But really cool in a lot of ways as well, because now you don't have to manage that whole process yourself. You don't have to make sure everything's patched to be up to date on all the server stuff. You don't have to, if your hardware fails, guess what? You're isolated from that. They just use some other server to host your virtual machine somewhere. So in a lot of ways, it frees you up from worrying about your machines as infrastructure as much. Of course, there's a whole new set of problems, like how do I get enough virtual machines when all of a sudden, you know, my website's featured on Reddit and now millions of people want to look at what I made. Cloud allows you to scale that up and down really easily so that you're only running as much hardware as you need to. But you don't need to think about that because AWS is handling that for you. Like internet usage for Netflix kind of looks like this, and this is quitting time, right? This is people come home and they're like, let's watch us some Netflix. So their usage is spiky. It's summertime, that goes up just because people aren't at work or doing anything. And so they don't want to operate at this capacity all the time, because when it dips down beneath it, that's money they're not making. That's money they're unnecessarily spending on web servers. So what they want is the ability to say, let me scale my operational costs based off of usage. And so they do that with cloud tech. And so the idea is, okay, I've got a bunch of different machines, virtual machines, and these can kind of live anywhere, and I'll connect them in some process. And certain parts of the application, we'll call that horizontal scaling, is when you just have more web servers. For example, if I've just got a fixed data set, like all of these can kind of be independent from each other, where they just all have a copy of the data set. And so 1 million people want to know something, and a server can only handle 1,000 people at a time. Well, I just need 1,000 web servers. And so the process of managing spinning that up and then going back down to, oh, the Reddit hug of death is over, I just need 1,000 web servers again. Well, I don't need to be paying for 1,000 of these. I'd really rather just go back to paying for one of these, things like that. Like another great example of this is Black Friday. Black Friday, the amount of infrastructure that you need to run your website goes up because the demand goes really high. Tons of people are going to be accessing your websites to be doing the Christmas shopping, whatever else. You need to be able to rise to that demand, and you're going to need to do it quickly. So you need a way to scale all your infrastructure. And that's what the cloud is all about. But yeah, to answer your original question, we just have someone else have a big box with all the files that we put in them, and then they give us back IDs for it, for how to pull them back out. The internet is crazy. Fortunately, you don't need to know it all at once.
Do we go into cloud in this course, or is that something that we'll have to do outside of class?
There's not a lot that we cover inside the class. We're mostly covering you from an application development point of view, where it's like, oh, I know how to make features on an app, because a lot of times that's where you start out. But the if you want to, you can go into cloud type stuff. We've had people from this class, like Michelle, go into working in cloud environments where they set all of that up. You'll be a junior, obviously, because you won't know much, but you'll have some coding experience. You'll know a little bit about web and other stuff like that. And a lot of times people, it's a direction you could go where you're managing, like you're a lot more in the operations side of things than necessarily the app development side of things. So like with HEB, you're not necessarily as concerned with, hey, we're going to redesign the user flow so that more people will sign up for curbside or something like that, or the information's easier to access, or we're going to let people look at what they're spending their money on shopping, like feature development like that. You might be like, okay, we're about to open up like 10 new stores. How do we make that work with our infrastructure? Questions like that. So it's like, it doesn't feel that different. The data might be a little bit different, but you're also looking at, okay, how do we use all these technologies to handle that kind of stuff? But that tends to be the more senior you get, the more you have to worry about the bigger system parts. Like when I first started, did not care about that. It's only later, and remember, I've been doing this like being in industry like a decade. So you've been in here, I think we're on week 9. So you have time to learn and think about that and sort of move within the space where you want to be. Yeah, that was a tangent. Wow, that was fun. Thank you, Jacqueline.
No, thank you. That was really interesting.
Yeah, the internet, man. The internet is crazy.
Oh man. All right, y'all.
Have a good one, Matt.
Yeah, cheers.
All right. Last call for questions at this point. I guess we're already a little bit over on time. Any final questions? All right. With that, we will call it a day. Thank you, everyone, for sticking around as long as you did. We will see you tomorrow where we'll talk more about Mongoose. Have a good one.